Okay, welcome back to 127. This is the 1, 2, 3, 4, 5, 6, 7th week, I guess, of crazy days. It's the 7th consecutive week of me not having it within my soul to shave my face. So I look a little homeless, but you know, whatever. I've had a couple of questions on the discussions about the final review. And actually the questions that were asked, most of them, when I worked them out, I got answers that were different from the review, which is actually a good sign to me that the questions that you're asking are essentially why the hell is the review answer key wrong. So that I'm happy about. We're going to go through a couple of problems. I've got them here, so let's start on number 7. We're going to do all of 7, so start here. Seven says A says the area of a triangle ABC. So I have some triangle ABC, and we're given the area is 25 root 3 square centimeters. We're not too concerned with units in this class, but it is square centimeters, so when you find a length, it'll be centimeters, right? Angle A is 30 degrees, so we have that. And side lengths B and C are the same, so this B down here is the same as this C. Whatever they are, I don't know what they are yet, but they're the same. Okay. And so we want to find the lengths B and C, right? And so I need to know the area formula, the area of a triangle. If I know the lengths B and C and then the angle between them would be 1/2 that B times C times the sine of the theta between the two, so sine of theta. But I know that this is equal to 25 root 3. And so I have an equation here, right? I know that B is equal to C, so I can replace B with C, or replace C with B, it doesn't matter. I can write this as 1/2 B times B, would be B squared, times the sine of 30 is equal to 25 root 3. Right? And I know everything in here except B now, right? Solve this for B, I've also solved it for C, and I've answered the question. So sine of 30, 30 is that shallow angle, so sine is the small, it's a 1/2. So I get 1/2 B squared times another 1/2 is equal to 25 root 3. So if I multiply both sides by 4, that'll kill my 1/2 and the other 1/2, and that'll turn it into 100 on the other side, but that gives me B squared equals 100 root 3. And to find B, then I just take the square root of both sides, and so I have a root under a root, but the square root of 100, I can take that out as 10, so I have B equals 10, and then I have a square root of 3 under a square root, that's a 4th root. And that's how we get that 10 4th root of 3 answer. I have, by the way, updated the problems that I did. The ones that I found were incorrect answers in the review, and after this video, while it's uploading, I will also upload that and replace the answer key on Canvas. So that is 7A. Seven B says that we're given another triangle. Some triangle ABC. Doesn't matter, ABC. And side lengths A. So A is across from the angle A. We've been calling it alpha primarily in this class, but if you see a capital A, that just means angle A, which is across from side length little a, right? We're given that little a is 6 centimeters And we're given that B, so across from capital B, is also 6 centimeters. I'm going to get rid of centimeters. It's just in my way more than anything. And then we have C is 4 centimeters. Okay. So we have that. We want to find the area of the triangle. I have no angles whatsoever, which means that I have two options. I can use the cosine formula, the law of cosines, to go through and figure out one of these angles, and then use the area, 1/2 a times b times sine of the angle between the two. Or I can use Heron's formula. Which I never liked Heron's formula, but this is what it's for, is an angle or a triangle like this, right? So in Heron's formula, remember that S is our semi-perimeter. It's A plus B plus C, all divided by 2. That's something you'll probably want to know. So this is 6 plus 6 plus 4, all divided by 2. That's 16 divided by 2, so S, the semi-perimeter, is 8, right? In addition to then that S, which I'm just going to clear up a little room here, maybe write it here, S is 8. The area of a triangle in Heron's formula is the square root of S multiplied by S minus A multiplied by S minus B multiplied by S minus C. It's a pretty simple formula. It's the semi-perimeter multiplied by the semi-perimeter minus each of the 3 legs, right? So this is the square root of S, which is 8, times S minus A, so 8 minus 6, times another 8 minus 6, times 8 minus 4. Which is to say I have the square root of 8 times 2 times another 2 times 4. Okay. And if I think of it this way, 8 is just 2 times 2 times 2 times my next 2 times my next 2 times 4, which is 2 times 2. I'm under a square root, so I can pull out one group of 2's, another one, and another one. So 2 times 2 times 2, that's 8. And I have a root 2 left underneath. I have 8 root 2. And that's my area. Let's look at 7C. What does 7C say? Find the area of the shaded region. Oh, okay, so we have this circle here. And some angle here. In fact, we're given that angle is 120 degrees. And then the shaded region is outside the triangle created by the secant line that goes through, bisecting at the radii of this triangle, right? And so I need to know 2 things here. I need to know the area of the sector, right? The area of the sector is that little, well, big in this case, piece of pi, right? So the area of this sector is 1/2 theta r squared, right? And it's important that theta is not 120 degrees. I need to convert that into radian, right? So my area of the sector is 1/2. My theta, I can put 120 degrees in here as long as I convert that. So I convert it by multiplying by pi over 180. So whatever the result of that is, that's my theta in radian. And then I have r, and r was given to me, even though I didn't read it out. R is 8. Right? And so I have 8 squared. So I'll just simplify stuff here. I have 1/2. 120 and 180, if you just divide them by 10, that gives you 12 over 18. Both of those are divisible by 6, giving you 2 over 3. Plus the pi, don't forget that, so I have 2 pi over 3 here. Times 8 squared, which is 64. And I can simplify the 2, cancels with the 2, and I'm left with 64 over 3. 64 pi, excuse me, over 3. Okay. So I have the sector. I'm going to erase this and just throw my value for the sector up here. That was 64 pi over 3. And the other thing that I want to find out here then is the area of the triangle, right? Because I have all of this area inside that sector, and I want to take out that triangle. So if I find this sector, I find the triangle, I just find the difference between the two, and that's my solution. So the triangle has area of 1/2 times A times B times sine of the theta between the two. Because I know A, that's the radius of this circle, and therefore it's the side length on both ends of this triangle. And so it's A 1/2 times 8 times 8 times sine of 120. Right? You need to know the sine of 120. You should know all of your sines and cosines of all the nice convenient angles, both in degrees and radians. But here I can take 8 times 8 is 64, and then divide that by 2 gives me 32. Sine of 120, right? You need to know where 120 is. It's over here. Right? 120. Right? 120 is 60 degrees less than 180. It's 30 degrees more than your 90. So it's the shallow degree off of the vertical straight up. But it's the same then as the sine of 60, and that's your larger value. That's your root 3 over 2. So 32 is divisible by 2. That gives me 16. So I have 16 root 3. Right? And there I have it. If I take this, my triangle is 16 root 3. Therefore, the shaded area is 64 pi over 3 minus 16 root 3. And again, I didn't write this review. I stole it from the professor that kind of put this course together, decades ago. She put this 16 root 3 over a common denominator, and in doing so she wrote the wrong value here. It should be 64 pi minus 48 root 3 all over 3. But, that's still correct. But again, you're taking a probably multiple choice heavy final exam, and so you'll need to know how to convert these, hopefully better than she did. All right, let's look at 7D. And then move out of 7. Okay, 7D says an isosceles triangle. Well, an isosceles triangle has two legs that are the same, and then one that may or may not be the same. If it is the same, it's an equilateral, so it's usually not. But it has an area of 100 centimeters squared. Okay. The angle between the two equal sides, so I'm calling these guys equal, so the angle between the two, I lost my place, is 5 pi 6. Right. What is the length of the two equal sides? So this is actually very much like 7, what was it, A? I don't know which one. But the area, right, this is the same as this, so I'm just going to call them both A. That area of 100 is 1/2 A times A, or A squared here, times the sine of the angle between the two, so 5 pi 6. Right? So that is to say that we have 100 is equal to 1/2 A squared. Sine of 5 pi 6 is 1/2. So I have essentially a 4 in the denominator here, because I've got a 2 and another 2, so I'm going to multiply 4 up to give me 400 is equal to A squared. And if I square root both sides, I get A is 20. It's plus or minus 20, but in the physical context of this, the negative 20 doesn't make sense, so it's 20. Okay, let's move on to number 8. Somebody asked a question about 8b. Which says we have the sine of x over 1 plus cosine minus the sine of x over cosine x minus 1. And then this whole thing is to the negative 1, right? So I can't do anything with this negative 1 because there's a sum or a difference in here, so I have to simplify this into a single fraction before I can then exercise that negative root. So I would do that by getting a common denominator, and that common denominator is 1 plus a cosine of x times the cosine of x minus 1. And just out of habit, I don't like that these two are different, the 1 plus cosine x, where over here the cosine x comes first. So I'm going to rewrite this guy right here. Instead of 1 plus cosine, I'm going to write cosine x plus 1. It's the same thing, it's just going to turn out a little bit easier in just a minute to see one of my steps. Right? But this needs a cosine x minus 1, so I multiply both the top and bottom, so this becomes sine of x multiplied by that, cosine of x minus 1, all over the common denominator of cosine x plus 1 multiplied by cosine of x minus 1. Minus, and then this cosine x plus 1 gets multiplied up, so I have sine of x multiplied by cosine of x plus 1, all over the combined denominator here again of cosine of x plus 1 times the cosine of x minus 1. Right? And don't forget that this whole thing is still to the negative 1. So the next thing I'll do is distribute my signs. So this becomes sine of x times cosine of x. So I'll just write it sine x cosine of x. Sine x multiplied by minus 1 is minus sine of x. All over that denominator. And I'm just going to multiply this here. You can see this is the stage where it's nice to have it in this format. Cosine x plus 1, cosine x minus 1, that's going to be the difference of two squares. That's going to end up being cosine squared of x minus 1. Minus, on the other side, when I distribute this, I get a sine of x cosine of x plus a sine of x. All over. Same thing, cosine squared minus 1. And again, don't forget this negative 1 is still out there because I can't do anything with it until inside of the parentheses are cleared up a little bit. Now I have them over common denominator. I can combine the two fractions now. Let me get a little space to do that. Maybe change the color of my pen so it doesn't look like I'm running into each other. But I can rewrite this then as the sine x cosine x minus 1, minus sine of x, my bad. Minus, and you have to be careful because this is minus that whole fraction, so it becomes minus sine x cosine x. and then minus sine x. All over that combined cosine squared x minus 1. And again, we're still under a minus 1 exponent, right? Now I can clear a little bit of stuff up. Let me clean my board up. But I can clean this fraction up quite a bit because I have a positive sine x cosine x and negative sine x cosine x, so they cancel each other out. They're gone. Minus sine x, that's minus 2 sine x over, and this cosine squared x minus 1, be careful with your Pythagorean theorem, that becomes a minus sine squared, right? Because I have sine squared x plus cosine squared x equals 1. If I subtract the sine x, the sine squared x, and subtract the 1, that gives me that cosine squared x minus 1 is equal to the negative sine squared of x. So watch out for the signs there, right? Make sure that if you do a Pythagorean, you can arrange it correctly so that you get the right sign. But that turns my denominator into sine squared of x. And again, don't forget, we have this negative 1 exponent. I can still simplify inside. A sign in the numerator will cancel a sign in the denominator. That's negative. I just said watch out, it's negative, and then didn't write it. And then the negatives will also cancel out, so this turns into 2 over the sine of x to the negative 1. Now the negative 1 is just going to flip my fraction, and so this becomes sine of x over 2. Which in the, I think the solutions say 1/2 sine x, that's the same thing. Right? Either one. All right, let's look at 17b. (17b) asks, yes, yeah. It gives you two numbers. We have a complex number z1 is 2 root 3 minus 2i, and z2 is negative 1 plus I. First thing it asks you to do is to write these in complex form or in polar form, right? Trigonometric form. And so I want to find, we'll call it R1 for the radius of the point 1 of our z1. And that's just the square root of 2 root 3 squared plus negative 2 squared, right? That's just the distance formula, the magnitude. So 2 gets squared, that's a 4. The root 3 gets squared, that's a 3. So I have 4 times 3, which is 12. Negative 2 squared is 4. And so this is the square root of 16, and that's just 4. Theta 1, which we'll say is just the theta of point z1, is the tan inverse of the y component, or the imaginary component, which is negative 2, divided by 2 root 3, right? And then be careful when you take the tan inverse, because if you throw it into a calculator, which you shouldn't have to, by the way, here, but if you do throw it into a calculator, it's going to spit out a value that may be wrong depending on if it's on the other side of the circle. So you always have to double check, right? If I think about where this point is, it's got a positive real and a negative imaginary, so I should be somewhere in here in quadrant 4, right? So if I look at this, I can simplify 2 and 2, and I can rationalize. This is then tan inverse of root 3 over 3, right? This one is actually the small, so that's the pi 6, and it's, sorry, negative, and therefore this is, I can call it negative pi 6, Or I can go all the way around and call it 11 pi 6. It doesn't matter. If I can write 11 without turning it into a pi. Right? Either one of those is fine. Right? It's the same spot. It's right here. Right? So I have that. I've got, let me just erase this and write Z1 then in its trigonometric form. My radius was 4 times the cosine of whichever one of these. Pick one, it doesn't matter. I'm going to go with a negative 11, or sorry, negative pi 6 plus an I sine of negative pi 6. Right? Okay. And then we'll do the same thing for Z2. Z2 has a radius of, we'll say radius 2 is the square root of negative 1 squared plus 1 squared, right? Because the coefficient in front of here, not written, is implied 1. But that's just 1 plus 1, and so I have the square root of 2. Theta 2, the theta of Z2, is the tan inverse of 1 over negative 1. That is, I have the tan inverse of negative 1. Right? And that's going to it's going to either be 3 pi fourths, or it could be on the other side of that, right? Negative pi fourths, or 7 pi fourths, whichever you want to write it, right? How do you decide which one of these is correct? Well, this point has a negative real, so it's somewhere over here, but a positive imaginary, so it's in quadrant 2, and that's 3 pi fourths, right? So it's not 7 pi fourths, it's 3 pi fourths. And so I have Z2 is, if I remember right, it was root 2 times the cosine of 3 pi fourths plus I sine of 3 pi fourths. Okay. Now the next thing they ask us to do is to find a couple of things, and I'll do a couple of them and then leave, I think, the last one probably for you. But Z1 multiplied by Z2 is the first thing they ask for. But that's just the multiple, the coefficients multiplied, so I have 4 multiplied by square root of 2 multiplied by a cosine of the sum of these things, right? If I'm doing a product, I add the angles. So it's convenient to have that negative pi 6 here plus 3 pi fourths. Because that keeps me within one circle here. Right? I need to get a common denominator here, so I'm going to turn this into, well, this is still 4 root 2. A lot of people shorten this whole big ugly thing while you're doing your work to CIS, meaning the cosine of the angle and the I sine of the angle. So I'm going to just stick with this because I get sick of writing this 1,000 times. But I'm really just simplifying this angle in here, and it's going to happen the same thing over here, so it shortens it so you don't have to write it twice. But I want this to be over 12, so I'll multiply this by 2 over 2, so I get 2 pi over 12. I'm going to multiply this by 3 over 3, so 9 pi over 12. Right? This whole thing then is equal to 4 root 2 times the cosine I sine of 7 pi 12ths. Right? So again, to write this back out explicitly, this means that that is 4 root 2 times the cosine of 7 pi 12ths plus the I sine 7 pi 12ths. Right? The other thing they ask us to do is the division, Z1 divided by Z2. And for the division here, instead of using negative pi 6, right, so when I do Z1 over Z2, I'm now going to come in here and say, I don't like that negative pi 6. What I do like is that it could also be 11 pi 6, and I'll replace that. Because z1 over z2 is the modulus, the radius of z1 divided by the radius of z2 multiplied, and again I'm just going to shorthand this because I get sick of writing cosine of blah plus the I sine of the same blah. So this CIS, you'll see it every once in a while. It's laziness. I'm being lazy. That's okay. Is the cosine and I sine of 11 pi 6 now minus 3 pi fourths. And this is why I chose to use 11 pi 6 here, so that I have a larger angle minus a smaller. I'm still going to land up in one circle, and I don't have to change my answer, right? Otherwise, I'd have negative pi 6 minus 3 pi fourths, get a negative number, and I have to add 2 pi to it, get myself back into that first angle. But this 11 pi 6, 3 pi fourths, let me start here. 4 over root 2. I feel like, yeah. So that's the same as 4 root 2 over 2, or 2 root 2, if you rationalize that. Times that CIS, the cosine, I sine of, turn these into 12s again. I'll do that by multiplying this by 2, so I have 22 pi over 12, minus 9 pi over 12, which is, this turns into 13 pi twelfths, right? And so to explicitly write this out, I have 2 root 2, CIS is the cosine of that angle, 13 pi twelfths, plus the I sine of that same angle, 13 pi twelfths. Done. Let's look at number 23. And we're going to do one of these problems. We'll do number 23D, which says, an airplane is flying at an elevation of 5,100 feet. Whatever. That's my airplane. Don't make fun. You can't do better. Just kidding. You probably can. But this thing is flying at 5,100 feet. And again, we're not going to worry about those units too much. It's just 5,100, right? And it has 2 motorists driving cars on the highway opposite sides of the plane. So one of them's in front, one of them is in back. It doesn't matter which one's in front and which one's back. You'll get the same answer no matter what happens. But let's just say that the front guy has that angle of depression of 30, right? So the angle of depression is the angle difference from the line of sight of the airplane, right? The airplane, the pilot is looking this way. This is the airplane's horizon. Right? As far as they're concerned, that's horizontal, right? So an angle of depression comes down off of that. The first one is a 30-degree angle of depression. And we have a car. It's the stupidest looking car ever. Again, quit making fun. But I've got that car, and then on the other side of this plane, there's an angle of depression from his rear horizon of 60 degrees. So that means this angle here is 60 degrees, and I have another car. Whatever. This is why I didn't go to art school, but probably should have. What we're really interested, though, in is not really these triangles here or over here, but this triangle here and this triangle here, right? Because what I really want to know is how far apart these two cars are, so I want to figure out this x1, which is the length that this one car is from the perpendicular, pole down from the plane. And then I have another one, x2, And so my answer is going to be x1 plus x2, right? And I don't know a whole lot of information about this angle. Let's look at the one on the left first. I don't know a whole lot about it, except I kind of do. Because if this angle up here is 60, well, the angle between the airplane's horizon and the ground has to be 90, which makes this a 30-degree angle right here. But I also know that this happens to be a 90-degree angle down here, so I happen to know two of those angles plus this side over here, which is 5100. I can use the law of sines here. So for x1, I would say that the sine of 30 degrees over x1 is equal to the sine of, I don't really want this. What I want is this other angle over here. If this is 30 and 90, that makes this guy a 60. And so I'm going to use it with coupled up with the 5100 feet. It gives me a sine of 60 degrees over 5100. Right? Okay. So the sine of 60 is 1/2. Well, let's solve this for x1. I would multiply my x1 up, and then in fact multiply the 5100 up. And then the sine of 60 is coming down, right? But the sine of 30 is 1/2. The sine of 60 is √3 over 2. I feel like I made a mistake on my work now, because I got something different. Let me check. No, I think we're okay. Oh, I did a different problem. This isn't the one I did. Alright, no worries. I will have to go back and check because I think I wrote this answer in for a different problem. Let's keep going on with this though. This can multiply up, so this becomes 2 over √3. So the 2's cancel out, so I get 5100 over √3. Right? Or I can call this 5100 √3 over 3. And 5100 is divisible by 3. And so I can call that 1700 √3. Okay. So I'll write that here. Okay. Okay. Okay, let's clear off a little area, and I can't find my eraser. There it is. This other one here has, if this is a 30, that makes this a 60 up here, which then turns this into a 30 because this is also a 90, right? So for x2, I can use the law of sines. The sine of 30 degrees divided by that 5100 should be equal to the sine of 60 degrees divided by x2. And therefore, my x2 I'm going to multiply up, multiply the 5100 up. Oops. And then the sine of 30 down. So this gives me 5100. The sine of 60 we just said was √3 over 2. And the sine of 30 is 1 over 2. So if I flip the 1 over 2 to be a 2 over 1 up here, that gives me 5100 √3. You know? And so this x2 is 5100 √3. I don't know where my green went. Everything's disappearing on me. Okay. And so x1 plus x2 is 1700 root 3 plus 5100 root 3, right, which is 6800 root 3. Okay, are we okay with that one? I don't know why I'm asking. None of you are going to be able to reply to me. If you're not okay with any of these, throw it into the discussions. We'll talk about them a little bit more. Okay. Let's look at number 24. And I did C. C says, a pilot flies in a straight path for 2 hours. She then makes a course correction heading 45 degrees to the right of her original course, flying 1 hour in the new direction. So she's flying, let's just call it north. She's doing this for 2 hours. And since she's going at 400 miles per hour, 200 miles per hour, then that means this is 400 miles total. Right. So the 2 hours is no longer significant. We know how long she went. She then takes a, and the wording here is not the best, but it says she's heading 45 degrees to the right of her original course. So her original course would be up this way. 45 degrees to the right of it would be that way. And so if you think about this as your x direction in this path, she's heading at a bearing of 45 degrees north of east or 45 east of north, right? But that's where she's going. She does this for 1 hour, which then means she went 200 miles. So I've got two things here essentially. I've got vector u, if you want to call it u, that's the very first distance she drove or flew, and then I've got this vector v where she turned and then went further. Vector u, since it's completely in the north or the positive y direction, has a vector of 0, 400. And then vector v has a magnitude of 200. And then I can say that it's just the cosine of 45 comma the sine of 45 degrees. Cosine and sine at 45 degrees are both root 2 over 2, so this vector v is going to be 200 times root 2 over 2 is 100 root 2. 100 root 2. Right. So I'm not really interested in this first one anymore. What I want to do is add u and v, because that's her final spot. U plus v would be this right here, is u plus v. So u plus v is 0 plus 100 root 2, that's 100 root 2. And then 400 plus 100 root 2, that's her distance, that's where she is. That's her specific spot of being where she is. Her distance then is the magnitude of this. And so the magnitude of u plus v is the square root of 100 root 2 squared plus this 400 plus 100 root 2 squared, right? This math turns into just ugly crap from here on out, and then it turned into a wrong answer in the review, however that happened. We shouldn't be too concerned with this. This is a major time killer. I've looked at your final exam. It doesn't have anything of this horrificness on it. So I'm going to skip the work a little bit, but know that when you square this 400 plus 100 root 2, it's a binomial because you can't combine those two terms. And so in the end, I got 200 times the square root of 5 plus 2 root 2. So it's an ugly answer. This is one of those that you would probably just say, estimate this sucker to the nearest tenth of a mile and call it good, right? All right. Okay, let's look at 24. Just kidding, that was 24. Let's look at 25. And I did 25C. 25C says that we have a triangle ABC with little a is 5 and little b is 5 root 2. And angle A is 30. And then we're asked to find angle B. So angle B, I can use the law of sines here. I have the sine of B over 5 root 2 is equal to the sine of 30 over 5. So I'm solving for B, so I want to multiply both sides by 5 root 2. So I'm going to multiply 5 root 2 up here, 5 root 2, that cancels the 5 root 2 on the left. The 5 cancels over here, leaving me with a sine of B is equal to the sine of 30, which is 1 over 2, and so I have a root 2 over 2. And you should know that the inverse sine, right, if B is sine inverse of root 2 over 2, that gives me a 45-degree angle, or pi fourths, right? But because of this angle side-side or side-side angle, whichever one you want to call it, it could also open up and be the other thick angle, so I could also have a $1.35 here, which is 3 pi fourths. So we have those two options here because of the nature of this angle. Let's look at 26. And there's, I don't know who did the numbering, but this is 26 part 2. Well, I do know the numbering. I'm just not going to name her or him. So 26 part 2. Says, migrating salmon heads in the north. So we have these bearings again. We didn't talk about these. They're not going to be on your exam. But it tells you that he's going 60 degrees north, 60 degrees east, right? What that means is there's north. That's your starting point. And you go 60 degrees east. So 60 degrees is here, and he's going in that direction. So in reality, you can just call this 30 degrees in our regular, angle coordinates that start at the positive x-axis and go counterclockwise. Okay. But this salmon is moving 6 miles per hour, so I'm going to get rid of the 60 right here and just write his velocity, 6 miles per hour, in that direction, relative to the water. If the prevailing ocean currents flow due south, so we have this water then that comes in due south at 2 miles per hour, it's going to, push that salmon down a little bit, right? And then it asks what the true velocity of it is as a vector, and then the true speed. And so the velocity, we have the velocity of the fish swimming, which is, he has a magnitude of 6, so multiply that by the cosine of 30, sine of 30. And then we have the velocity of the water, which is completely in the south, so that's 0 in the x or y direction, 2 in the negative direction because it's south, right? The combination here, well, let me just write this vector up here. Cosine 30 is root 3 over 2, so I have 6 times root 3 over 2, which is 3 root 3. Sine of 30 is 1/2, so 6 times 1/2 is 3. And then again, the water was 0, negative 2. So the combined velocity is 3 root 3 plus 0, or 3 root 3, comma 3 minus 2, or 1. So that's the true velocity of the fish relative to the land, to the earth, whatever you want to call it. They also asked for the speed. The speed is just the magnitude of the velocity, so that true velocity, if you want to call it true, doesn't matter. The magnitude of that is the square root of 3 root 3 all squared, plus 1 squared. 3 gets squared to be 9, root 3 gets squared to be 3, so I have 9 times 3 is 27, plus that 1, so this is going to end up being the root of 28. That was 26. Let's look at one last one here. It's 31D. So 31 says, complete the square to determine whether you have an ellipse, parabola, or hyperbola. And then we're given something, again, kind of in an ugly format. It's x squared plus 16 equals 4 times y squared plus 2x. Right? So before I start worrying about completing the square, I first want to get everything onto one side, and I'll start by distributing to break up this right-hand side parentheses. So I end up with x squared plus 16 is equal to 4y squared plus 4 times 2 is 8x. I'm going to subtract those and bring them to the left, so that'll give me x squared minus 8x. I'm going to write that plus 16 right here, minus 4y squared, and then on the right-hand side I have 0. Right? So I wrote this specifically because this is already a perfect square trinomial. This is x minus 4 squared, so the square has been completed for us. Minus, and you can think of this as y minus 0 squared, right? And so it looks like we're going to have a hyperbola centered at 4, 0, right? But on the right-hand side, it's not equal to 1, right? If it were equal to 1 over here, it would be a hyperbola. It's not. When it's equal to 0, that is a degenerate. Doesn't look like degenerate, but what? It's a degenerate, right? And what happens in this case is it's no longer a hyperbola, but I can move this term over to the right-hand side, and we'll see that this will probably turn into 2 lines. So I'm going to move it back over, so I have x minus 4 squared on the left is equal to 4 times y, well, I'm just going to write 4y squared. On the right. If I square root both of these, then I can call this just x minus 4, throw a plus or minus over here to be 2y. Right? And you can see that I do indeed get two lines. If you want to divide by this plus or minus 2, then that gives me plus or minus 1/2 x. Well, plus or minus 2 is equal to y. Right? In fact, let's do this. It would be minus plus, meaning that if you go with a plus for the 1/2, you go with a minus for the 2. It doesn't matter. It's two straight lines. They intersect. That's hardly the point of what we care about right here. Alright, so that should do it for the questions that I had on the review. Again, if you have any other questions, go into the discussion boards, throw them there. I'll be watching them. For Math 127, remember that your final is on next Friday, the 15th of May. It's going to be open between 8 and 5. Get in there, give yourself enough time. If you log on at 4:30, and then realize that you need 3 hours to do the exam, that it sucks to be you. There's nothing I can do about it. It's department rules. Get in there, get your test done with plenty of time so that you don't run out of time and get a bad score just because of time management. Thanks again, and there's a link, I believe, that should have been sent to everybody about course evaluations. Go ahead and click that. Tell them that you love me, that you hate me, that coronavirus sucks, whatever you want to write in there. Go in there, post that. You can also, if you really feel like it, rate my professors. You can go on there and tell the world that I'm awesome or that I suck. Don't do that. Either way, but other colleges are actually starting to look at those, and I teach at 3 right now, so yeah, if you love me, and I know you do, right? Anyway, just do that, but worry mostly about your final exam. So I'll see you guys, and I'll keep you guys updated through the discussions. I've left the final exam discussion open, so you guys can keep posting any problems in there. Thanks.